Hello, my dear students. Today we are going to discuss general revision on chapter 1, which is transition elements. We are going to discuss different types of questions and we are going to show their model answers. So let us start. First type of question is choose the correct answer. The element in which its outer levels have the electronic configuration 5f14, 6d6, 7s2 is from what? Transition series. Is it first, fourth, second, inner lanthanides? If you think about it, my dear student, you will find that it is from fourth transition series as shown on the screen. Next one. Element which is strong as steel but less dense. Here is it scandium, titanium, iron, zinc. If you think about it, my dear student, it will be titanium. Next point. Its density decreases. If you think about it, yes, it is difficult to be oxidized. Next point. Magnetic moment for the paramagnetic substance increases by increasing of what? Is it atomic number, mass number, number of single electrons, number of paired electrons? If you think about it, my dear student, yes, the answer it will be number of single electrons. Next point. Zinc 2-ion is colorless and has diamagnetic property due to what? Presence of 3d paired electrons, 3d sublevel is filled by 8 electrons, 3d sublevel is filled by 5 electrons, the presence of unpaired electrons in 4s. If you think about it, yes, it will be the presence of 3d paired electrons. Next point. The atomic number of metal, its magnetic moment is 2 equals what? 23 or 29, 21, 22 or 28, or 27. If you think about it, my dear student, yes, it will be 22 or 28. Next point. Iron 2-ion is characterized by its paramagnetic property due to what? Presence of 3d unpaired electrons, 3d sublevel is filled by 10 electrons, 3d sublevel is empty, the presence of unpaired electrons in 4s. If you think about it, my dear student, you will find the answer is presence of 3d unpaired electrons. Next point. All the following ions are paramagnetic and colored except what? Is it vanadium positive 2, copper positive 2, copper positive 1, iron positive 2? If you think about it, yes, it will be copper positive 1. Next point. Iron is found in free state in what? Siderite, meteorites, Earth's crust rocks, alumina. If you think about it, yes, it will be meteorites. Next point. On heating iron 3 oxide in the presence of mixture of carbon monoxide and hydrogen gas, it is reduced to what? Is it iron 2 oxide, magnetic iron oxide, iron, or mixture of iron 2 and iron 3 oxide? If you think about it, yes, it will be iron. Furnace that reduce iron ore by water gas is what? Is it blast furnace, matrix furnace, electric furnace, oxygen converter? If you think about it, yes, it will be matrix furnace. Next point. Furnace that reduce iron by carbon monoxide gas is what? Is it matrix furnace, blast furnace, electric furnace, oxygen converter? If you think about it, yes, it will be blast furnace. Next point. It will be main transition elements. Successfully filled. If you think about it, yes, it will be second transition series. Next point, the absorbed color from visible spectrum by transition element. Yes, it is supplementary color. The reflected color from visible spectrum by transition element, if you think about it, complementary color. Next point, elements that have partially filled D or F sublevel in their free state or ionic state. If you think about it, yes, transition elements. Next point, the oxide formed when red hot iron reacts with air or steam. If you think about it, yes, it will be magnetic iron oxide. The oxide formed when magnetic iron oxide is heated in air. If you think about it, yes, it will be iron 3 oxide. The type of iron oxide that reacts with dilute acid, if you think about it, yes, it will be iron 2 oxide. Next point, the type of iron oxide that reacts with hot concentrated acids forming iron 2 and iron 3 salts. If you think about it, yes, it will be magnetic iron oxide. The types of iron oxide that doesn't react with diluted acid, if you think about it, yes, it will be iron 3 oxides and magnetic iron oxide. Alloy of two elements or more, their atoms have the same diameter, chemical properties, and the crystalline structure. If you think about it, yes, it will be substitutional alloy. One of the iron ores which has blood red color, if you think about it, yes, the answer it will be hematite. Next point, heating iron ore strongly in air to be dried and to expel humidity and to increase the percentage of iron. If you think about it, yes, it will be roasting process. An alloy formed when its elements are chemically combined. Yes, it will be intermetallic alloy. Next type of question, choose the correct answer. When magnetic iron oxide reacts with hot concentrated sulfuric acid, what is produced? Iron 2 sulfate and water, iron 3 sulfate and water, iron 2 sulfate and iron 3 sulfate and hydrogen, iron 2 sulfate and iron 3 sulfate and water. If you think about it, yes, the answer it will be iron 2 sulfate and iron 3 sulfate and water. On passing hot steam over red hot iron, it gives what kind of oxide and hydrogen gas? Is it iron 3 hydroxide, iron 3 oxide, magnetic iron oxide, iron 2 oxide? If yes. The reason for that, because sulfuric acid is a strong oxidizing agent, giving both iron 2 and iron 3 sulfate. As the equation proceeds on the screen, iron plus sulfuric acid concentrated in the heat gives iron 2 sulfate, iron 3 sulfate, and sulfur dioxide, and water is produced. Next point, iron does not react with concentrated nitric acid. The reason for that, because of the formation of non-porous layer of iron oxide that preventing further reaction with the acid as passivity occurs, where, my dear student, the non-porous layer of the iron oxide has larger size than the metal molecule, preventing further reaction with the acid. Next point, pure iron has no industrial use or not preferable to use iron in pure state because it is relatively soft, low hardness, malleable, and ductile. Next point, heating iron 2 oxalate gives iron 2 oxide, not iron 3 oxide. The reason, because the produced carbon monoxide gas is a reducing agent that prevent formation of iron 3 oxide. Heating iron 2 sulfate gives iron 3 oxide, not iron 2 oxide. The reason for that, because the produced sulfur trioxide gas is oxidizing agent that prevents the formation of iron 2 oxide. Alloys of scandium with aluminum is used in make fighter jets. The reason for that, because the scandium is less dense and hard. Scandium is used in TV photography at night because it is added to mercury vapor lamps to produce light with high quality, looks like sunlight. Next point, alloys of titanium with aluminum used in space shuttle and aircraft. The reason for that because titanium maintains its durability at high temperature while hardness of aluminum decreases. Titanium is used in dental implants and artificial joints. If you think about it, yes, it will be because titanium is inert substance, so the body doesn't eject it and it doesn't cause any type of poisoning. Next point. Titanium dioxide is used in some protection cosmetics. The reason for that because titanium nanoparticles prevent the ultraviolet light to reach the skin. Next point. Vanadium steel alloy is used in car spring. The reason for that because vanadium gives the steel hardness and corrosion resistance. Next point. Chromium is highly reactive but resists the effect of air due to the formation of non-porous layer of chromium oxide layer, which are larger in size than the metal molecules that prevent more reaction with air, that we call passivity. Next point. Manganese is not used as pure metal because it is brittle and is used in form of alloys or compounds. Next point. Ferromanganese alloy is used in railway track because it is harder than steel. Next point. Alloys of aluminum and manganese are used in manufacture of cans because alloys of aluminum and manganese resist corrosion. Next point. Cobalt is used in detecting cracks and welding connection cans. The reason for that because it emits gamma rays which have high penetrating power. Next point. Alloys of nickel and chromium are used in manufacture of heating coil and electric furnace. The reason for that because they resist corrosion when they are heated to red hot degree. Next point. Nickel is used in painting metals. The reason for that because it gives better appearance and also resists rust. Next point. Fehling solution is used to detect glucose sugar because its color changes from blue to orange. Next point. Zinc is used in galvanizing metal. The reason for that because it protects metal from rust. Next point. Abnormal electronic configuration for chromium and copper. The reason for that the electronic configuration of chromium, 24 atomic number, argon 18 for S1 3D5, that the 3D is half filled, which have lower energy and extra stability. And in copper, the electronic configuration argon 18 for S1 3D10, the 3D sublevel is completely filled, which is more stable and less energy. Next point. Transition metals show several oxidation states because their valence electrons in 4s and 3d sublevels are near to each other in energy, so they lose the electron from them successfully. Next point. All first transition series have oxidation number positive 2 except scandium has only one oxidation state, positive 3. The reason for that, when scandium has electronic configuration argon 18 for S2 3D1, loses 2 electrons from the 4s and 1 electron from 3d sublevel, it gets an empty d sublevel, which is more stable. Next point. The maximum oxidation of the first transition series increases from scandium positive 3 till manganese positive 7. The reason for that, because losing the electrons from 4s and the 3d sublevel according to their oxidation state. Next point, the oxidation states from first transition series decreases from manganese to zinc. The reason for that, the increase in ionization energy as the increase in positive nuclear charge. And in copper, the electronic configuration argon 18 for S1 3D10, the 3d sublevel is completely filled, which is more stable and less energy. Next point. Transition metals show several oxidation states because their valence electrons in 4s and 3d sublevels are near to each other in energy, so they lose the electron from them successfully. Next point. All first transition series have oxidation number positive 2 except scandium has only one oxidation state, positive 3. The reason for that, when scandium has electronic configuration argon 18 for s2 3d1, loses 2 electrons from the 4s and 1 electron from 3d sublevel, it gets an empty d sublevel, which is more stable. Next point. The maximum oxidation of the first transition series increases from scandium positive 3 till manganese positive 7. The reason for that, because losing the electrons from 4s and the 3d sublevel according to their oxidation state. Next point, the oxidation states from first transition series decreases from manganese to zinc. The reason for that, the increase in ionization energy as the increase in positive nuclear charge. My dear students, we have finished our program today. I hope you understood all the different types of questions that we discussed today and their modern answers. So till we meet again, my best wishes.